Hello, all you meatballs. Let's greet each other properly. Good morning. It's good to see you guys. Virtually, that is. Hey, listen, we're going to get into another lesson here, part two of the translation series called Glide Reflections. And we have a very specific goal here, and we want to translate and reflect now a point or a set of points given a set of rules. Okay, this is called a glide reflection. All right, glide reflection. So we're going to do both kind of both transformations that you've been learning, uh, not excluding the rotation, but we're going to translate and reflect now, given all sorts of rules. So here we go. Let's get right into it. Before we do, get out a red pen and a highlighter. Okay, red pen and highlighter here, so we can highlight the results. All right, make your stuff look good. Okay, be detailed, do a good job, make yourself proud, as I always tell my son. All right, so here we go. What we're going to do is we're going to, given the pre-image here, which is what we're starting with here, this is called the pre-image. As you guys know already, pre means before. So before you translate it or move it or shift it or reflect it or anything, you have what's called a pre-image, the original figure. And what we want to do here is take the translation vector and translate the figure first, then reflect it over the x-axis. So the very first thing we got to do is we got to translate it, all right? And then secondly, we got to reflect it over the x-axis. All right, one thing at a time. Now when you look at the translation vector here, we start here and we end here, right? And so what do? Well, we count 1, 2, 3, 4 to the right, so we got to go 4 to the right, and then we got to go 3 down. So let's write 4 down 3 for every vertex. All right, so let's do that. All right, starting with A. So we go 1, 2, 3, 4, down 3, 1, 2, 3, and there's A prime. All right, you got to label your vertices too, by the way. All right, be diligent and label your work as you go, okay? All right, so that's A prime. For C, we got to go right 4 down 3. So 1, 2, 3, 4, down 3. All right, there's C prime. And then for B, 1, 2, 3, 4, 1, 2, 3 down. There's B prime there. And then you connect your primes, okay? You get what's the image. So get out your straight edge. And you got your first image. All right, so let's highlight that just for funsies right now. Okay, so there's your image, your first image, before you reflect it. So this is your first image. All right, now we got to reflect that over the x-axis. And as you guys know, the x-axis is right here, the horizontal one, and you're going to reflect it over the x-axis. So if you start off with the figure below it, then you reflect it above it, right? So all you have to do is count the units below the x-axis. It's always the same distance, opposite side. Same distance, all right, opposite side. If you look back at your previous notes, well, we wrote down that, okay? So when you reflect any figure over any line of reflection, in this case, the line of reflection here is the x-axis, well, you just count the units. So since A prime is 1 unit below, then A double prime is 1 unit above. C prime is it's 4 units below, so C double prime is 4 units above. 1, 2, 3, 4. All right, and call that C double prime. All right, and then B prime, well, it's 2 units below. Just look. Okay, you can see. There, so you go 2 units above. That's B double prime. Everybody say B double prime. Okay, there we go, and you connect. All right, so then you go from A double prime to B double prime to C double prime, and you have the third or the second image or the resulting image. Okay, you can call it whatever you like. I just call it the end result. All right, so after you reflect across the x-axis, this is what you get. All right, this is the end result. All right, and we're happy because we did it right. So we translate it first, given a translation vector. Okay, take a look at this. Let me show you some vectors here. So from B to B prime, we translate it first according to my translation vector, which C went to C prime, A went to A prime. I'll show another vector right here. Well, I'll show them all. All right, just for funsies right there. So there you go. And so you translate it first. Translate means shift. Remember that. Translate, shift, slide, however you want to say it, right? They all mean the same thing. So you slide it or shift it first, and then you reflect it. How do you reflect it? You reflect it over the x-axis, okay? And that is called a glide reflection. So it glides to the lower right, and then it gets reflected, hence the name glide reflection, okay? And that's all there is to it. So what we're going to do here, guys, is just go through a series of examples and take a look at all the different possibilities. Now, on this one here, we want to translate it first again, all right? And then secondly, we want to reflect over the x-axis, or excuse me, y-axis. Let me highlight that. The y-axis, okay? And that's the vertical one. All right, so what does this translation vector say? Well, it says, hey, move every single vertice 3 right. So that's -3, go 3 left. Excuse me, I said right, I meant left. I'm goofball, okay? So go 3 left and then 2 down, okay? So 3 left and 2 down. So left 3, down 2. Okay, that's what that translation vector tells me to do. So we're going to do that. So go 3 left from A. So go 1, 2, 3, 1, 2. Simple. There's A prime. All right. For B, 1, 2, 3, down 2. There's B prime. C prime. 1, 2, 3, down 2. There's C prime. Okay, and let's connect. Get your straight edge out. Be diligent. Be exact. Make your work look good. All right, so there we go. There's my first image. All right. After I translated it, how? Well, I looked at the translation vector and it says move 3 left and down 2. So from 8A prime, I went 3 left, all right, and down 2. And you do that for every single vector, all right, or I mean for every single point. Now we have to reflect it over the y-axis, okay? Now the y-axis is vertical, right? You guys know that. So we want to reflect it across here, right there. Now take a look at C prime. I'm going to start here. It's 2 units to the right. So you go 2 units to the left. All right, and you get C double prime. Everybody say C double prime. Okay, C double prime. All right, and then B prime, well, it's 1 unit to the right. So we go 1 unit to the left. All right, and A is 4 units to the right, so we go 4 units to the left. 1, 2, 3, 4. All right, oop, that's a double. Okay, double up on that, and then A double prime here. All right, again, we reflect it across the y-axis. So if it starts off on the right, then it's the same distance and opposite side to the left. All right, get your straight edge out, make it look good. All right, and there we go. And that is my second image after you reflect it. So we glide, and then we reflect. All right, glide, I guess, is like a shift, right? You know that. All right, so there you go. So once again, when you reflect across the y-axis, goes on the opposite side. Okay, reflect across. All right, so you translate first, make it glide, and then you reflect, hence the glide reflection. Okay, and that's number 2. Okay, number 3, let's take a look at a different case. Now, this case, I don't give you a translation vector. Oh my goodness, what happened to my grid? My grid's all messed up. It's messed up on a lot of these, though. This is not going to be good. Let's see if I can pull this off. Okay, so I'm just going to go with it, guys. So here we go. So I'm going to translate it first, okay, and then after that, I'm going to reflect over y equals x, and so we need to recall how to do that. Ooh, okay. So you have to remember how to do that. So let's see, let's interpret first. You take any point and it gets translated 2 units right and 5 units down. So this is right 2 units and this is down 5. Okay, that's what it means to this part right here. X plus 2 means right 2. The y minus 5 means down 5. That's the first interpretation that you have to understand. So instead of me giving you a translation vector, I give you a translation rule. All right, which tells me I got to take my triangle and go right 2 down 5. Okay, so right 2, 1, 2, down 5. So, so I'm going to have to estimate here because I don't have my grid. It's not going to be fun here. So 1, 2, 3, 4, 5. Okay. Hmm. I wish that didn't happen. Okay, we'll go with the flow. So right here, this is A prime, and then we're going to do the same thing for B. So go right 2. So 1, 2, down 5, all the way down here. All right, B prime. And then C, you got to go right 2. So 1, 2, down 5, 1, 2, 3, 4, 5, right about here. And this is C prime. Okay, then go ahead and connect. Yours should be more accurate than mine because I'm not working with a grid right now. I'm estimating. So that's the beautiful part about graph paper, okay? All right, so you translate it first according to your translation rule, which means right 2 down 5. There's my translation right there. I just showed you vector right there. And I went right 2 down 5. And then now I've got to reflect it across y equals x. Now, y equals x. Y equals x has a slope of 1. Y equals 1x plus 0. So the slope is 1 and the y-intercept is 0. So we're going to need a graph y equals x first. Then I'll talk about it. So here, here, here. And then at, let me see, 8, comma 8, 10, comma, let me see, 8, 2, 4, 6, 8. So slope of 1. So you start, go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. So 4, comma 4 should go through there. So let's draw the line y equals x. This is right about there. Something like that. I don't have graph paper here, so I'm estimating. So we graph the line y equals x. And what you guys need to remember is that when you reflect over y equals x, the rule that we wrote down was that every point x comma y gets switched. All right, y comma x. So y comma x. This was you switch coordinates. If you look in your note cards, well, that's what we wrote down. This is the y equals x reflection rule. Okay, so let's do that. So on this one here, let me write down a prime here. So a prime, what does it look like? It looks like 7 comma 1. C prime, what is that? 5 comma negative 3, so 5 negative 3. B is 4 comma negative 1, so 4 comma negative 1. So what you want to do is switch coordinates and then graph. So a prime gets, when you reflect it across y axis x, becomes 1 comma 7. So where do you graph that? Well, 1 comma 7 is 1 right, 7 up, which is right about here. So that's a double prime. So a double prime, 1 comma 7. You switch the coordinates. That's all you do. Notice the same distance opposite side right here. 5 comma negative 3. If you switch that, you get negative 3, 5. So left 3 up 5. Right about here. That looks pretty good. So C double prime at negative 3, 5. And then B, you got to switch that, negative 1, 4. So negative 1, 4 is right about here. B double prime. All right, and then you connect. So let me see, where is that? You got to connect all the double primes. All right, and I'll shade that in. Okay, so when you reflect it, it's the opposite side, same distance, opposite side. Remember when I did this? Watch this. All right, B prime goes to B double prime. C prime goes to C prime goes to C double prime, and then A prime goes to A double prime. It's the same distance, but opposite side. Same distance, opposite side. That's the concept of a reflection, guys. Okay. So on this one, though, like I said, right here, when you reflect over y equals x, you have to remember that all you do is switch coordinates. So write all those key things down. They're on your note cards and your trace paper and wherever you put them, okay? But that's how you do it. Well, let me highlight the first image here. So we went from the pre-image, the given one right here. This is your pre-image. This is what we start off with here, pre-image. Then we translated it, became to the yellow one, A prime, B prime, C prime, and then we reflected it. All right, that's example 3. All right, let's do another one that's slightly different. Okay, so on this one, I want to translate it first. Again, in every glide reflection, you translate then reflect. So we want to translate it first. All right, and then we need to reflect over here over y equals negative x. Okay, and I do not know what's going on with my graphing program here. I can't believe I don't have coordinates. Okay, I'm going to pause for it for a minute. Okay, sorry about that interruption there. I had to figure things out, and I fixed a few things. So here we go. Example 4. So one more time, we need to translate it first according to our translation rule, and then we need to, right here, we need to reflect it across the line y equals negative x, all right, which is different than the previous one. So on this one, there we go. On this one here, we want to interpret first. So instead of giving you a vector, I gave you a translation rule. So this means left 1, and this means up 3. All right, so I want to translate it first. Translate it left 1 up 3 first, and then I'm going to reflect it across the line y equals negative x. So here we go. We're going to go left 1 up 3. So left 1, starting in A here, just go 1 to the left and up 3. 1, 2, 3, and that's A prime. And then do that for every point. Left 1, up 3, and you get B prime. At C, you go left 1, up 3, and you get C prime. And then same thing with D. Left 1, up 3, and you get D prime. And then you connect. Now, anytime you translate an object, you got to keep in mind that it's the same shape and same size. All right, this is for translations now. Okay, same shape. All right, same size. There are isometries. If you didn't hear me, let me say that again. Okay, it's an isometry. Isometry. Okay, same shape, same size for all translations and reflections, even rotations. All right, not dilations, but on all the other ones, there are isometries. So you can check it with trace paper if you want. Okay, and you get this. You get this image here. Okay, so we start off with a pre-image that's given. This is the pre-image. And then we translate it. Okay, so let me draw my little vector here, my translation vector from A to A prime. So we translate it first, according to my translation rule, left 1 up 3. And then now I'm going to reflect it across the line y equals x. Now, excuse me, y equals negative x. Now y equals negative x, remember that the slope is negative 1. Slope equals negative 1, which is negative 1 over 1. So you got to go down 1, right 1. So when you plot this line, starting at the y-intercept here, you got to go down 1. Why did I say? I said right, but I wrote down left. So I mean down 1, right 1. So from the y-intercept, you go down 1, right 1, down 1, right 1, down 1, right 1, and step it out. Okay, and then plot a lot of points. And you reverse it. You go up 1, left 1, and you plot a lot of points for the line y equals x. You do that because you want to graph it correctly. So let's do that. Okay, so get out your straight edge and let's draw the line y equals x. There we go. Okay, excuse me, y equals negative x. Come on, Ainsworth. So, and then we want to reflect that. Okay, so we need to reflect that. How do you do that? Well, remember that for this kind of translation, we said that every point, what you do is you switch and take the opposite. So you should get negative y comma negative x. You switch and take the opposite. So let's see that. So what I'm going to do is I'm going to write down the coordinates first. So 2 comma 6 right here. This right here is 6 comma 7. So 6 comma 7. D is 5 comma 5. C is 3 comma 4. I do that because when I switch and take the opposite here, it's much easier to do that if you can see the coordinates. So here we go. So 2 comma 6 becomes negative 6 comma negative 2. So negative 6 comma negative 2 becomes right here. So and that's b double prime. Negative 6 comma negative 2. 6 comma 7 becomes negative 7 comma negative 6. So left 7, down 6, 2, 4, 6. Right down here, so this is a double prime at negative 7 comma negative 6. 3 comma 4 becomes negative 4 comma negative 3. So left 4, down 3. And that's c double prime. So negative 4 comma negative 3. And then 5 comes negative 5, negative 5. So left 5, down 5. And that's c double, no, d double prime. And then you connect. And shade it in. That's your final image. That's the end result. Okay, and remember, it's always the same distance opposite side. So when you reflect b prime to b double prime, it's the same distance opposite side. And from c prime to c double prime, same distance opposite side. And then d prime to d double prime, same thing. Look right there, boom, right there. And then a prime to a double prime, same distance opposite side. If you don't want to draw the translation vectors, no problem. Okay. Actually, that wasn't a translation vector. That was just showing you where b prime got reflected to b double prime and so on. If you don't want to draw that, that's fine. It's just I was showing you that this distance here from b prime to the line of reflection is the same as the line of reflection to b double prime. Same distance, opposite side. That's all. So if you didn't want to do that, you could do this. Don't show them. This is our end result. Okay? But if you want to show them, hey, why not? I'll do it just once. B prime to B double prime. Same distance, opposite side. Remember that. From here to here, same distance from the line, opposite side. That was the concept that I went over again and again about reflections. So remember that. Okay, we're almost there, guys. Example 4. Okay, now example 5 is similar, a glide reflection that's a little bit different. We translate it according to the rule, and then we reflect it over y equals 2. All right, that's the second thing we need to do. So we go right 1, all right, down 3. All right, right 1, down 3. Okay, that's how we're going to translate it first. So let's do that. So we go right 1, down 3, a prime, right 1, down 3, to d prime, right 1, down 3, to c prime, and then we get b prime. So then you connect and you get your first image. I'll shade that in just for funsies right there. There we go. Okay, so I translate it first, and now I reflect it across y equals 2. So you got to remember that this is a horizontal line. So y equals 2 looks like this. Ooh. Get your straight edge, guys. All right, don't do what I'm doing here. Use your straight edge. So this is y equals 2, and you want to reflect across this line. So it goes up top. All right, and so let's see, b prime, it's 4 units away from the line of reflection. Not from the x-axis, but from the line of reflection. So b double prime should be 4 units above. 1, 2, 3, 4. So this is b double prime. Okay, c prime is, well, let me see, it's 4 plus 2 is 6. So we count up 1, 2, 3, 4, 5, 6. And there's c double prime right here. And then a prime is 3 plus 2 is 5. So 1, 2, 3, 4, 5. A double prime, d prime, let me see, it's 5 plus 2, 7. So 1, 2, 3, 4, 5, 6, 7. Way up here, there's d prime. And then you connect. The way you can check this to see if you hit all the vertices right is by take a piece of trace paper, all right, and trace the original and the end result, and they better be the same shape, same size. Okay, you got to reflect across. Reflect across. Okay, y equals 2. And so you got to go across it. Okay, same distance, opposite side. This distance right here is the same as this distance here. Okay, they're both 6 in this case. I think, let me see, 1, 2, 3, 4, 5. Oh, excuse me, 5. 1, 2, 3, 4, 5. Yeah. Okay, same distance, opposite side. This is 5 units below, then A double prime is 5 units above. Okay, so you translate and then reflect. The glide reflection. All right. Next one. Number 6. A little bit different now, right? Because each one of my examples is different. So on this one here, you interpret the translation first. It says right 6. So we go right 6. All right, and then we go up 3. So you interpret first, and then you reflect over this line. All right, we'll get to that in a minute. So the very first thing we do is we go right 6, up 3 on every point. So right 6, 1, 3, 4, 5, 6, 1, 2, 3. It's a counting exercise, guys. There's B prime. 1, 2, 3, 4, 5, 6. 1, 2, 3. A prime. 1, 2, 3, 4, 5, 6. 1, 2, 3. B prime. Oh, excuse me, D prime. Let me fix that. 1, 2, 3, 4, 5, 6. 1, 2, 3. And there's C prime. Connect. All right, and there's your first image. Okay, and then, so after you translate it, let me just draw a translation vector here from D to D prime just to show. All right, and then you got, B to B prime and so on. Then what you want to do is you want to reflect across x equals -3, which is a vertical line. All right, so where is it? It's right here. It's the vertical line going through x equals -3. It's -3 on the x-axis there. So this is x equals -3, and you want to reflect across it. So it starts off on the right, then the image must appear on the left. Okay, so on this one here, let me see, B prime is 1 unit away, so B double prime is right here. A prime is 1, 2, 3, 5 units away, so 1, 2, 3, 4, 5 units away on the other side, A double prime. C prime is 2 units away, so C double prime is right here, 2 units on the other side. And D is 4 units away, so 1, 2, 3, 4, it's right here. D double prime, and then you connect. Okay, and there you go, and you shade it in. There we go. And remember, a reflection, it's the same distance on opposite sides. So B prime goes to B double prime, C prime goes to C double prime, and so on. You reflect across. Okay? You reflect, it's the same distance, opposite side. Same distance, opposite side. Okay? That's for all reflections. All right, that's how easy it is, my friends. Okay, last example. Let's put it all together here. All right, number 7. Holy cow, look at this. We got 4 things to do. Well, 6 things. Okay, so given the pre-image, we want to translate it first. Right 2 units. Look at this. You interpret that as right 2, and this is up 3. So you go right and up. All right, and then we reflect it across the x-axis, and then reflect it across the y-axis, and then reflect it across y equals x, one at a time, and then we write down the end results. Okay, so we got to go right 2, up 3. So here we go. Okay, right 2, up 3. So right 2, up 3. There's B prime, A prime, C prime. Okay, connect. Believe it or not, it's this fast and this easy. Okay, as once you understand. So we got the first image here done. Let's look at the directions now. So you translate it first. Let me show the translation vector from B to B prime. Right there. Up 3, right 2, or right 2, up 3. however you want to say it. All right, and then what does it say? Reflect over the x-axis. Okay. All right, so here's the x-axis. So you got to reflect above it. Okay, so let me bring this down here. So this is B double. This is B prime here. So B double prime. Let me see. Let me switch to blue. B double prime is here, 1 unit above. A double prime is 2 units above. C double prime is 3 units above. And then you connect. Okay, and then you follow the directions, right? And then you reflect over the y-axis. Okay, so let's do that. All right, let me switch colors here. So green. So the y-axis is here, and you reflect over. So A double prime is 3 units to the left. So A triple prime is over here. A triple prime. B triple prime. Let me see. B double prime is 7 units. So 1, 2, 3, 4, 5, 6, 7. It's way over here. So this is B triple prime. And then C double prime is 6 units left. So we gotta go 6 units right. Right here. 1, 2, 3. C triple prime. Everybody say C triple prime. Okay. And then you connect. And then you shade it in. All right. So you make your work look good. Look at that, man. Ooh, yeah. Okay. So then we reflect it across the y-axis here, and then we reflect it across y equals x. That means you switch coordinates. Okay. That means that x comma y becomes y comma x. All right. You switch coordinates. So on this one here, you might want to write them out. So let me see. A double triple prime is 3 comma 2. And this is 7 comma 1. And this one is 6 comma 3. And then you just switch them. All right, so we switch them. Okay, so 3 comma 2 becomes 2 comma 3. So right up here, a quadruple prime. So a 1, 2, 3, 4, a quadruple prime. Ooh, I got too many primes there. All right, at 2 comma 3. And then 7 comma 1 equals 1 comma 7. So 1 comma 7 is way up here. That's B quadruple prime. And that's 1 comma 7. And then 3 comma 6 becomes 6 comma 3. No, excuse 6 comma 3 becomes 3 comma 6. Got that backwards. There you go. So C triple quadruple prime, 3 comma 6. And then you connect. All right, so connect. And you switch colors again. I don't know. Right here is this. Looks good. Okay, so this is across the line y equals x, right? So let me plot y equals x just so you can see it. There's line y equals x. Okay, so y equals x is here, and we reflect it across it. Okay, see that? Reflect across. So you just switch coordinates. Hopefully that's what I said there. Let me see. Yep. Okay, and then what we want to do is highlight the end result and state the coordinates. Okay, and I already have them written down right here. So the coordinates are, for A, it's 2 comma 3. A quadruple prime, B quadruple prime is 1 comma 7, and then C quadruple prime is 3 comma 6. All right, that's my end result, and I'm happy, man, because that was cool. All right. All right, so here we go. So we translated, we reflected across the x-axis, and then we reflected across the y-axis, and then we reflect across y equals x. My friends, that's the last few lessons all put together, except the rotations. All right? If you understood all that, then you are the man. Or you know, whatever, you know what I mean. All right, so anyways, this is Mr. Ainsworth. We're done. Practice, get good, and I will see you in my next lesson. I am signing off. This is Mr. Ainsworth. See you later. Bye bye.